we are going to start a new topic, that is accuracy and precision. So the topic we are going to start today is accuracy. So accuracy and precision. Precision. Whenever we do measurement, we have to have both accuracy and precision to get the best answer, get the closest answer, in order to have good data to follow. So first of all, let's know what accuracy and precision is. So before we even start, there's something that you must know. So this is something like a note. That is accuracy, accuracy and precision are different concepts, are two different concepts. So whenever I say a data is accurate, it does not mean that a data is precise. And whenever I say data is precise, it may or may not be accurate. So it may be or it may not be. So first of all, let's talk about those terms, accuracy and precision, in detail. So first of all, let's talk about accuracy. So what is accuracy? So when talking about accuracy, accuracy is the degree of closeness, the degree of closeness or agreement or agreement of of measured value with with the true or standard value is called accuracy. So accuracy is the degree of closeness or agreement of measured value, um, with true or standard value. So it's actually checking how close are you with the real value that's technically used in real life. So good accuracy, good accuracy means the reading, the reading or mean of set of readings, set of readings, is very close, is very close to the true value. So the key point that you have to see here is mean, the word mean. So the mean value must be close to the true value. It's not every single value must be close to the true value, it's that the mean should be close to the true value. So there can be some something like some instant where it is very far from the actual value, and sometimes it is very close to the actual value, but in general when we take the mean, we get the in a general sense. So whenever we take the mean, so when mean means taking all the experiments, the data from the experiment, and taking their average basically. So we will get an average approximation of where the thing might be, and that thing must be near the true value. So now another point, to evaluate to evaluate the accuracy to evaluate the accuracy of a measurement of a measurement, it must be compared it must be compared to the true value. So in order to check for the accuracy, you must know the true value. So let's pick out some important highlight points in this. So it's the degree, accuracy is the degree of closeness or agreement. And good accuracy or reading means mean. It talks about mean. Mean must be very close to the true value. And finally, to evaluate the accuracy, we must compare it to the true value. So we must compare it to the true value. So these are the most important things that you must know when talking about accuracy. So now let's talk about precision. So the next topic we are going to discuss is precision. So what is precision? So when talking about precision, the degree the degree of reproducibility um, the degree of reproducibility of a measured quantity is called precision. So it deals about reproducibility. So how easy it is to reproduce and how close do you get when it reproduces. So smaller smaller the value of least count. So least count is the minimum measurement that it can do. For example, a normal scale has a least count of 0.1 mm, which is millimeter. 0.1 millimeter, it can't measure better than 0.1 millimeter. So that's the least count of an instrument. So least count, smaller the least count of the measurement, or sorry, the instrument. So instrument, better will be the precision. So if we have a smaller least count, we will have a better precision. So good precision, good precision means the reading, the reading, the readings are mostly, the readings are mostly very close or to their mean value. So in the previous case, so if you go to accuracy, it is compared to the true value. Here it is compared to the mean value. So that's very different, since the mean value may not be the accurate data. So the key points here are the degree of reproducibility of measured quantity is called precision. It depends on the least count. So smaller the least count, better the precision of the instrument. So if the least count is down, the precision increases. And the spelling of precision is wrong, so let me write it again. Precision. So the smaller the least count, the greater the precision. And finally, it's to their mean value. It's not to the true value, it's to the mean value. The mean value meaning the value that's that arrived due to the readings that you took, not the actual value. So now let's compare accuracy and precision. So here let's do accuracy, and here let's do precision. Let's create a basic. So I think this will be about the halfway point. Pretty sure that will be about the halfway point, and we can make the pretty brackets later on. So for accuracy, the first point that we're going to talk about is accuracy is the accuracy is the accuracy is the closeness with the true value of the quantity being measured, whereas precision can be defined as um, precision is a measure of measure of the reproducibility, stability of the of the measurement. And the second point that we're going to talk about is measurement measurement can be accurate, but not necessarily but not necessarily precise. And similarly, measurement measurement can be precise. It can be precise, um, but not necessarily but not necessarily necessarily RLY accurate. So let's make some brackets to make it look a little bit prettier. So that's the outer bracket. Let's add some more brackets to divide them. So now let's move on to the next page. We're gonna continue this. So to continue this, again, let's write accuracy right over here, and precision right over here. So let's copy the lines which we will paste right over here. Now let's go. So the third point that we are going to discuss is, for accuracy, it can be determined with a single measurement with a single measurement, since you can just check the single measurement with the actual value to see if your value is accurate or not. Whereas for precision, um, uh, it needs several measurements to be determined, since if you have two values, or you need to measure a lot, since you have to check them with your values, not the true value, your values. Suppose I got 1 2 3 suppose I did several experiments. For accuracy, only one experiment will also be fine. So for example, I have to find the refractive index of glass by some experiment. If I got 1.4, that would be a very accurate result, since the actual true value is 1.5. So that would be very accurate. And for precision, suppose I got 1.3, then I got 1.33, then I got 1.29, then that would be very precise, since the measurements are of the same, are related. Even though it's not near 1.5, it's 1.3, it's still, the several measurements are actually close. That's why it will be a precise result but not accurate. So let's get to the fourth point, um, which is accuracy depends on simple techniques of analysis. Since you're just looking at the value you got and the value that is the true value, or the value that is followed. And for precision depends upon many factors many factors and many sophisticated 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 techniques of analysis. Since we have to deal with means and talking about standard deviations and stuff like that, that we will learn more about in math. So let's make some brackets. um, so one bracket right over there. Let's move this a little bit to the down, and boom. So now let's talk about some more points. So let's write accuracy and precision. Let's get the middle line from here and let's write the points. So the fifth point in accuracy is measurement can maybe um, maybe close to the standard measurement. And in here, um, measurement will be similar sorry similar similar every time you measure. So in accuracy, measurement will be close to the standard measurement, whereas measurement will be similar every time you measure with the values that you have measured. So that's the difference or comparison between accuracy and precision. So if you're pretty smart, then you might have understood what I just said. But if you're like me, you pretty much have no idea what I'm talking about, because even I didn't get the explanations that I was saying. I was just speaking. I didn't understand what I'm saying. So to understand this, let's take a look at some pictures that I'll show you right now, and which will give us a good sense of understanding what is precise, what is accurate, and stuff like that. So first of all, let's learn individually. Then after that, we will combine the pictures so that we can understand it more easily. Since I have to draw a picture, it's a little bit hard. But so before that, let's talk about something like a note, which is a high quality a high quality measurement should be both precise and accurate. So we will also see this in the pictures quite quickly. So for the pictures, let me draw something real quick. Might not be the best thing, but we're just gonna try to make it as good as we possibly can. So let's go here. Let's make some circles. Move this to the center. Make some more circles. So you can skip forward if you like, but hopefully you don't. Just stay here with me when I make them circles. I do love some circles. They're very I like the shape. Very fun to draw. Not fun to draw, but very fun to see, and also quite fun to draw when you're using when you're using like PowerPoint to like draw them. I don't know if they're equally divided, but I'm just trying to make them work. So let's group them. And let's keep it over here. So the first one we are actually gonna see will be let me fix this, which is accurate and sorry, let's see accurate and precise. Since we talked about measurements should be both accurate and precise, so let's take some examples. So if this is a dartboard, the closer they are, so suppose this is the target, so that's the target. Think of a dartboard. The closer you go over here, suppose in this area, the better you get your scores, right? So that's the concept that we're using. The closer you are to this, the better you scored. So suppose we have datas like 1.001 kilograms, 1.000 kilogram, 0.999 kilogram, and 1.002 kilogram. So look at the values. They are very close. Suppose our object is that we are trying to measure is 1 kilogram. Suppose the object that we're trying to measure is 1 kilogram. So look at the values. They are very close. So they are very close to 1, as well as they are very close to 1 as a number, and each other, the difference between any of the pairs are also very less. It is also very less. So if this was a dartboard, let me get some, suppose let's take this, most of the points will be like this. Suppose the 4 points, this is 1 kilogram, there will be 1 point because it is 1 kilogram, and some other points will be like this. So this is very high accuracy and high precision. Why high accurate? Because it lies in this part. It is very close to 1 kilogram. Each data is close to 1 kilogram. And why is it precise? Because each data is very close to each other. So when looking at precision, we are not talking about the data, we're not talking about the data compared to the actual data. We're talking about the data compared to each other when we're talking about precision. And when we're talking about accuracy, we're talking about the value of data related to the true value. So let's take another example. So this is accurate and precise. So you might still not get it. So when we're done with every single choice that we can do, which is accurate and precise, accurate and imprecise, inaccurate but precise, and inaccurate and imprecise, you will understand what we're talking about. Plus we are gonna combine them in one table as well. So pretty quick. So this, now we are gonna talk about accurate but imprecise. So we are going to talk about accurate but imprecise. Suppose the value we need is actually 1 kilogram, and we don't get exactly 1 kilogram, so it's 1.173 kilogram, 1.284 kilogram, 0.881 kilogram, and 0.917 kilogram. So if you take the mean, it will come very close to 1 kilogram. So the mean, so let's take another color. So here the mean is approximately 1 kilogram, right? Since the object that we are measuring is 1 kilogram, but the difference between the values are quite drastic. So if I draw them in the graph, it will be something like this. So as you can see, the distances are not that close, but as a whole, the mean average comes to about there, which makes it accurate. It is accurate because the mean is very close to the value that you need, to the true value, but it is imprecise because the each value is quite far from each other. So even though these are actually quite near, so I shouldn't have made them so far, you understand what I'm trying to say. So what I'm trying to say is that the mean is very close to the true value, but the points itself are not that close. Now, the third more case, which is that we're going to talk about. So we talked about when a data is accurate. So let's talk about when data is only precise. So inaccurate inaccurate but precise. Suppose the object is still 1 kg and we get the values of 2.814 kilograms, 2.834 kilograms, 2.822 kilograms, and 2.819 kilograms. Um, the mean of this value or any value in general is not close at all to 1, which was 1 kg, which was the measurement we are trying to take. But each value is very close to each other. So look, every single one has 2.8 followed by something else, but 2.8 is constant in everything. So here, the value is inaccurate because none of the data are close to 1 kilogram, which was the actual thing we were measuring, but it is precise since everything comes out to 2.8 kilogram. So in this case, the instrument might have some error. So if you have to plot them, so since they are not close, so they will not be here, so they will be there. But since they are very close values, they will be all bunched up. So this is very precise data since you're hitting one spot, but it's inaccurate because you're not hitting the correct spot. So like here, it's both accurate and precise because you're hitting the spot as well as you're hitting close to the spot. Here, it is accurate because in average, in a mean, you're hitting the spot, but it's imprecise because you're not close at the spot. It's not close. So now, the final one, which is inaccurate and imprecise, which is basically useless for us. So, inaccurate and imprecise. So if a data is not accurate and not precise, it does not give us any value. So for example, we are still measuring the 1 kgs thing. So suppose we have 0.312 kilograms, then we have 6.398 kilograms. After that we have 2.141 kilograms and 0.805 kilograms. So look here, none of the values are close to 1 kilogram except this one. This is quite close, but the average is not close to 1 kilogram at all. The mean is not close at all to 1 kilogram. And the value, when you take any pair, the value difference is quite high. So it is not accurate and is not precise as well. So for example, so when we're drawing it, it would actually look like this. So here, it's not near the actual value and it is quite far. Plus, if you take the mean, it will fall somewhere around here. The mean will be somewhere around here, which is not close to the true value. So that's why this is inaccurate and imprecise. So now, let's take all of them. So first of all, let me group all of them so that I can put them in one place. So let's take all of them. So see the pictures and remember what I taught you. So get a grasp of accuracy and precision, which are very important to know when you're doing calculations on science or math. So let me take this one. Let me keep it over here. Let's move this. Let's make it a little bit smaller. Now this second one. Again, take this out. Lower it down. Then move it to the side. The topics are going to be a little bit small, so don't mind that. So take this, copy that, move it down there, shrink it, then move it down. So look at everything you're seeing right here and try to understand the concept that I'm trying to teach you. So basically, this is it for today's video. In the next video, we are going to actually talk about significant figures, which is also a very important topic. I think they're very too small, so let me just change the thickness so that it will be much more easier to read. I think this will be much more easier to read than others. So with that, I'm going to end the video today. In the next video, we are going to learn about significant figures. Till then, bye.